more about trig functions, but we can introduce this idea of radian measure. Now, all radians are is an alternative unit of measurement. It's much like in length, I could measure in meters, centimeters, the metric system, or I could use feet, inches, the imperial system. It's just another way of measuring. Now, with angles, degrees obviously is the most common one that we look at before now, but radians actually is the more effective angle measure when it comes to engineering, science, maths, things like that, because it makes the calculus work basically. So the conversion is pi is 180, but I don't think of it as pi is 180. I think of it as 360 degrees, so a complete revolution is 2 pi radians. And I suppose the reason I think of it that way is I can get in my head real easy, because I know circumference is 2 pi r, and there's 360 in a complete circumference. So in my weird little head, I can go, oh yes, 360, 2 pi, that makes sense. Okay, so there's our conversion. 360 degrees is 2 pi. So the common ones we're going to see a lot are all those exact values that we learned. So 30, 60, and so on. Now, so 30 degrees ends up being pi on 6. So remember, pi is representing 180 degrees. 45 will end up being pi on 4. 60 is pi on 3, which brings about the first unfortunate thing about the factors of 180, because you'll notice 30 is pi on 6, 60 is pi on 3, are very easy to confuse the two and associate the 3 with 30 and the 6 with 60. It's the other way around. So always remember, it's 180 divided by, so if you're thinking about that. 90 ends up being pi on 2. And then we go into our second quadrant, and 120, which would be 2 pi on 3. 135 is 3 pi on 4. 150, 5 pi on 6. And again, if you're ever unsure, go back to the simple one. Go, oh, 150, and then remember, oh, well, 150 is 5 times 30, and I know pi on 6 is 30, so I get 5 pi on 6. And 180, so all the way around, is pi radians. Now, I want to avoid another bit of confusion that sometimes happens. Pi still is 3.1415, etc., etc., etc. Pi has not magically now become 180. Pi radians, so 3.14159, etc., etc., radians is equivalent to 180 degrees. But pi is not 180. It's still 3.14, etc., etc., etc. Okay, let's go to our third quadrant. 210 becomes 7 pi on 6. 225, 5 pi on 4. 240, 4 pi on 3. 270, 3 pi on 2. We get to our last quadrant. 300, 5 pi on 3. 315, 7 pi on 4. 330, 11 pi on 6. 360, 2 pi. So these are the ones we'll see a lot. Because, and you've probably noticed in the questions already, we've seen the exact values pop up a lot, because then you can just substitute in rather than having to go to a calculator. 1 on root 2, root 3 on 2, whatever it happens to be. Well, 67 then, how on earth would I convert that into radians? Well, if it's not one of those exact ones, or if I forget how to do an exact one, I simply multiply by pi on 180. And so it would be, and 67 doesn't go into 180, so it actually stays as that. 67 pi on 180 radians. The actual value of that, if you had to work it out, remember, pi still represents 3.14, etc., etc. So you would still use the pi button on your calculator and go 67 times pi divided by 180, 1 point. So you can see a radian is much bigger than a degree, because 67 degrees there is 1.169 radians. Or if you think about it, 1 degree would be pi, yeah. So it's a very small number of radians. So 36 degrees would be 36 pi on 180. That one does simplify nicely to be just pi on 5. And going back the other way then, if I have pi on 8 radians, well now it'll be, I'll multiply by the reciprocal, multiply by 180 on pi. The pi is nicely cancelled in this one, and I get 22.5 degrees. it doesn't have to have pi in it. It doesn't mean I can't see a pi, so it mustn't be in radians. It's still just a number. So 111.1, I'd still multiply by 180, divide by pi, and that one is around about 6,365.6 degrees. I think you'd be quite dizzy if you were moving through that many radians. Okay, so that's all I really need to say. 14A is just basically converting, a couple of questions with them, getting used to the idea of playing with radians. And so tomorrow we can get into the theory.